Alright, welcome to Algebra 1B Credit 4. In this credit we're going to be talking about quadratic equations and modeling, and specifically the big focus on this credit is actually on factoring quadratic equations to find solutions. So if this is your first time even attempting algebra, that means nothing to you. So let's just jump in to the credit. We're going to start by talking about some of the prerequisite skills that we need before we can actually start factoring quadratic equations. And so here we are with question number 1. We're going to do a crash course on exponents, because you will need to understand how exponents work when dealing with quadratic expressions and equations. So let's take a look at the example first. 8 to the power of 5 times 8 to the power of negative 2. Now we're not going to delve too much into exponent operations, but here's one thing that you should know, right? This part of the exponent, or this part of the term, is called the base, and this little itty-bitty number here, that's the exponent. Okay, and so the thing that we want to know, that is important to know about the exponent, is that the exponent tells you how many times you're going to multiply the number by itself. So specifically, 8 to the power of 5 means 8 times 8 times 8 times 8 times 8, or 1, 2, 3, 4. You're multiplying 8 to itself 5 times, right? That's specifically what we're doing here. So, just cutting to the chase, here's a shortcut. When you have the same base, right, as these two terms do, 8 to the power of 5, 8 to the power of negative 2, and you're multiplying them, when you're doing that, you can actually just add the exponents. So 5 plus negative 2 gives you 3. So this is much better than 8 to the power of 5, and then think about 8 to the power of 2. 8 to the power of 3 is literally just 8 times 8 times 8, 1, 2, 3 times, therefore the exponent. And if you punch that into the calculator, you do get 512. Now, I went through that really quickly. Like I said, this is a crash course on exponents now, so if that made no sense to you, pause the video, rewind, and take a listen again, or go find a Khan Academy video or something that talks about exponents, or ask your math teacher, because you can't spend too much time on this. So at least in this video, we're going to assume that you have mastered this skill already. So let's practice this skill. Okay, question number 1. We have the same base here, 3 and 3. So all we're going to do is we're just going to add those exponents. So 7 minus 3 equals 4. Therefore, this is like 3 to the power of 4, which is also 3 times 3 times 3 times 3. 1, 2, 3, 4 times. And so when you do that and you punch on the calculator, you should get 81. Okay. Question number 2. 7 to the power of 7 and 7 to the power of negative 5. They have the same base. So we're just going to add these two numbers together. 7 minus 5 gives us 2. So this is technically 7 to the power of 2, which is 7 times 7, which is 49. Okay, question number 3. Look at this. We have 3, and they all have the same base. So all we're doing is we're adding these numbers. So 9 minus 4 minus 5. That actually gets us 0. And like I said, crash course, when you have something with power of 0, it's just 1. It always is. Now, explaining why it's just 1 is another maybe 30 minutes into itself, and I don't want to do that. So just know that anything to the power of 0 is 1. 1 million to the power of 0 is 1. 1 billion to the power of 0 is still 1. Infinity to the power of 0 is still 1. So that's all you need to know for now. All right. So there's your crash course on exponents. Let's talk about algebraic expressions. So when we have two binomials like this, x plus 7, x minus 3, we're going to learn how to multiply these. Now, if this is your second attempt at algebra, you might have learned the FOIL method. I actually despise the FOIL method. Okay, despise is a little bit strong, but I don't like the FOIL method because I feel like there's a much more intuitive method that also helps us in the future when we're going to be factoring these quadratic expressions. So instead of FOIL, right, which I'm not going to do, is we're going to use the box method, right? And the box method is called the box method because you literally draw a box, and then you take the two binomial terms. So in this case, x plus 7, I'm just going to write it on top, x and 7. I'm going to take the second binomial term there, x minus 3. Okay, Okay, and notice how I wrote that, right? And then we're going to multiply out those terms there and see what we get in the box. So x times x is going to give us x squared. X times 7 is going to give us 7x. And then x times negative 3 is going to give us negative 3x. And then negative 3 times negative 7 is going to give us negative 21. And then we're just going to combine like the, well, first of all, let's write this one term first, x squared. Then we're going to combine the like terms right here in the diagonal. 7x and negative 3x will combine for a positive 4x, since it's 7 minus 3 essentially. And then the last one, the negative 21, is just going to hang out there. So this is what we get, and sure enough, just like the FOIL method, we should get the same answer right here, x squared plus 4x minus 21. Now, as far as why I prefer this method to the FOIL method is because with the FOIL method, there's a lot of lines, and it's not too much to think about when you have two binomial terms. But if you have two trinomial terms, right? If you have 1, 2, 3 multiplied by another 4, 5, 6, right? This gets really super confusing, right? Where do you draw the line with the? So anyway, too many lines. I prefer the box method for that reason. And so if you like using FOIL, go ahead and use FOIL. I'm not going to do that. And you'll also realize why I don't do that later on when we learn how to factor these quadratic equations, which is essentially we're going to go from here and here. That's what factoring is. Anyway, let's use the box method on these as practice. And so take as much time as you need. Pause the video if you need to. But anyway, let's get started. So we're going to draw that box again. And you might be asking yourself, how do you know what kind of box to draw, right? If it's 1, 2 terms, and this is 1, 2 terms, right? You're going to draw a 2 by 2 box. Okay, so we have a 2 by 2 box here. So I'm going to take this, I'm going to take this x minus 4 and write on top here x minus 4, and then this x plus 5 is going to go on the side here, x plus 5, and I don't write the plus because it's positive 5. Let's go ahead and multiply these. X times x is x squared, and then x times negative 4 is going to give me negative 4x, and then x times 5 is going to give me 5x, and then 5 times negative 4 is going to give me negative 20. And so let's go ahead and write it out now. The x squared goes in front, x squared. Then 5x minus 4x gets me just 1x, or sorry, just a positive 1x. We don't write that 1, it's redundant. So that's just plus x. And then lastly, minus 20, way at the end there. Okay, so x squared plus x minus 20. And that is our answer. Okay, question number 9. Okay, again, let's draw a 2 by 2 box since we're multiplying two binomial terms, x minus 9 here, and then x minus 6 here. Okay, let's multiply that out. X times x gets us x squared. X times negative 9 gets us negative 9x. Negative 6 times x gets us negative 6x, and then negative 6 times negative 9 gets us to positive 54. Let's write out what we have, x squared. And then we're going to combine these two, negative 6 and negative 9 combined to form negative 15x. And then that last term there is 54. So x squared minus 15x plus 54. Question 10. All right, so here we have another two binomials, binomial expressions there. We have 2x minus 3 and then 2x plus 3. And so let's go ahead and multiply these out. 2x and 2x gets us to 4x squared. 2x times negative 3 gets us to negative 6x. 3 times 2x gets us 6x. And then lastly, 3 times negative 3 gets us to negative 9. All right, and this one's interesting because, okay, let's just go ahead and write this out first. 4x squared, and then 6 and negative 6 are going to cancel each other out, right? Yeah, the same thing. 1 minus 1 is 0. 6x minus 6x is also 0, so we're not even going to write it. We're just going to write the last term there, negative 9 at the end. So here's our answer, 4x squared minus 9. Okay, lastly, question number 11. Right, we'll draw the box out again, and we have 3x minus 2 2x and 5 on the side there. So 2x times 3x gets us 6x squared. 2x times negative 2 gets us negative 4x. 5 times 3x gets us 15x. And then 5 times negative 2 is negative 10. And so let's combine these terms, or at least write out the first term first before we combine 6x squared, and then let's combine these. 15x minus 4x gets us to positive 11x, because 15 minus 4 is 11. And then the straggler there, the minus 10 is our answer. 6x squared plus 11x minus 10. Okay. All right, so that was that page 7. Let's jump into page 8. Here are a couple more prerequisite skills you need to know. Here, they're going to give you a value for b, and you're going to do something that seems kind of random. You're going to plug it into this weird expression here, or this term here, b over 2 squared. Right now it means nothing to you, but later on when we actually start learning how to complete the square, it will mean something. But for now, all we need to do is be able to procedurally understand that we're just going to plug this in here and see what pops out. Okay, so in this case, or let me go through the example first. Maybe we should have done that. So b equals 18, so you're going to plug that in here, and so instead of b, you're going to plug in 18, right? Because that's where we get that. So 18 divided by 2 squared, right? 18 divided by 2 is 9, and then you're going to square that, so 9 squared is 81. So we're going to do that for question number 4 here. We're going to plug 24 into this thing here, right? So we're going to write 24 over 2 squared. So let's do what's inside the parentheses first. 24 divided by 2 is 12. And then don't forget the square, which we got right there. 12 squared is 144. Okay? Again, it seems a little arbitrary, but it'll make sense when you get to the part of the credit where we're actually completing the square. All right, let's do the same thing again. We're going to plug this this is b value into this weird function that they've given us, 10 over 2, or 10 divided by 2 squared. So negative 10 divided by 2 is what? Negative 5 squared. And when we do that, negative 5 squared is 25. Since it's negative 5 times negative 5. Okay. Question number 6. Let's put that into this function again, b over 2 squared. Oh, why did I just write b? I need to write 3 over 2 squared, and in this case, 3 over 2 gives us 1.5, and I guess you can work with a decimal, but I don't want to do that. I'm just going to square this. 3 squared is 9, 2 squared is 4, and so if we're leaving in terms of fraction, you could do that, or you can make it a mixed number. What is it? 2 1/4, right? So either one of these answers is correct. All right. Question number 7, 8, 9, and 10. Okay, so these are going to seem confusing because you're going to learn how to factor, and yet they want you to factor this using these arbitrary rules. So not my favorite way to teach this because it's super confusing if you don't understand what you're doing. But because we have to do these problems anyway, let's just go with it. What they want you to do is to be able to see, right, that this is a perfect square. And again, if this is your first time, you might be like, what are you talking about? How the heck is that a perfect square? It looks nothing like a square. It looks like letters and numbers, right? Well, you just need to fit it into this form, a squared plus 2ab plus b squared, where this is the a term and this is... anyway, so let's figure this out, right? We have this, if we look at the actual problem we're using, x squared plus 14x plus 49, x squared, right? You can break x squared down into the square root of x squared is just x. The square root of 49 is 7, right? So this becomes our a, this becomes our b, and then all we're going to do is plug those in. A goes here and a goes here, and then b goes here and b goes here. And then as long as you have two pluses, right, you get x plus 7, and since you have two of them, it becomes x plus 7 squared. Okay, so even as I say it, it sounds so confusing, and if this is your first time, I can imagine how confusing this must be. So just bear with me for a second, because when we actually learn how to factor, it'll make much more sense, what I'm saying. But for now, the curriculum writers have, in all their wisdom, decided that this is the best way to do it, which honestly I'm going to disagree with, but it is what it is. So let's deal with it. X squared. The square root of x squared is just x. The square root of 36 is just 6. Or if we're being mathematically correct, it's actually plus or minus 6. But let's just go with the positive version of it. And so here we're going to write x and 6, and then x and 6. And I haven't written down the operations yet, but here's what you need to know. It's going to be x minus 6, x minus 6. How do I know that, right? Especially because, look, these actually say plus. Why is this one going to end up being minus, right? And it's because of this minus sign right here. I just know from experience that they're both, the factor form of this is going to have two minus operations here. And if you don't believe me, we can actually do the box method again, which I will, just for the sake of explaining this real quick. And x times x is x squared, x times negative 6 is negative 6x, negative 6 times x is negative 6x, negative 6 times negative 6 is 36, and again, if we write it out, x squared minus 12x plus 36, and sure enough, that's what we got right here, right? So anyhow, the example doesn't give us how to do this, so I feel like it's unfair, so just follow along. I don't know what else to tell you. This one has two pluses, so it'll fit the example much better. But let's think about this. What's our a term? What's our b term? Square root of x squared is just x. Square root of 121 is 11. And so what we're going to end up with is x plus 11 times x plus 11, which you can actually rewrite as x plus 11 squared, since you have two of them. Okay, so that one fits the example much, much better. All right, let's look at this one. Oh, look at this, plus and plus. So what's our a term and what's our b term? Well, the square root of 4x squared is 2x. The square root of 9 is 3. And so it's just going to be 2x plus 3 squared. Let's just jump straight to the shortcut. Why not, right? I mean, it's already a pretty messed up problem. So let's go from there. A term is going to be 4x. The square root of 16 is 4. And square root of x squared is x, and then we got square root of 25 is 5. Oh, and look at this. It's a minus, so we're going to end up with two minus signs, just like this first one here. So this is our answer, 4x minus 5 squared. Okay. All right, so we're going to jump straight into page 9, learning how to solve equations by factoring, and all this is okay. So let me get one thing straight before we jump into this. I am not a fan of how they teach factoring in this particular credit. So we're actually not going to do any of this after this video, right? So starting from video 2 of this credit, we're never going to identify P and Q and B and C and all that stuff like they're trying to make us do here. But we are going to do it for this video just for the sake of answering these problems. And so here we go. So they want you to be able to identify P and Q. This is P, this is Q, or vice versa. It doesn't really matter which one you pick, but let's just say the first one is P, the second one is Q. So how do you find B and C, right? Well, they tell you that B is going to be P plus Q. So you add 2 and 3 and you get 5, and that's B, right? Don't ask me why. They just tell you that that's what it is. And then C is P times Q. So 2 times 3, which we get from over here, is 6. And so C is 6. And then what you're going to do with that information, B and C, is you're gonna check by multiplying, right? If you do the box method, they want to know what you get, and sure enough, if you do the box method on x plus 2 and x plus 3, and here they're actually foiling, what you end up with is the second term and this third term, right? So that's what they mean by B and C. Again, this seems super confusing, and we're not going to do this again after this credit because I really don't think the way that they teach factoring quadratics is very intuitive. So if this method is not for you, don't watch the video for this credit, because we're going to do something completely different. Okay, so here we go. They want you to identify P and Q. Here's P, the first one, 8. Q is the second one, 9. Okay, find B, which is P plus Q. So 8 plus 9 is going to be what? 17. So B equals 17. And then C is going to be P times Q. So 8 times 9 is going to give you what? 72. And then they want you to check by multiplying. So let's go ahead and check by multiplying. Yay, B, so X plus, so hold on, let's do the box method again. So we got X and 8 on top and X and 9 on the bottom here. So X times X is X squared. X times 8 is 8X. 9 times X is 9X. And then 9 times 8 is 72. And then when we combine like terms in the middle there, we get X squared plus 17X plus 72. And sure enough, here's our B term. And here's our C term, 72. Okay. Yay. And then let's do the same thing for question number 2. And this will be the last time we do B and C and P and Q. 8 is P. Negative 7 is Q. So let's go ahead and find B, which is P plus Q. So 8 minus 7, this is going to be 1. So B equals 1. P times Q. So 8 times negative 7 gets us to negative 56. So that's C. And then if we go ahead and multiply that out, X plus, so let's do the box again. X, 8, X, negative 7. X times X is X squared. X times 8 is 8X. X times negative 7 is negative 7X. And then negative 7 times 8 is negative 56. And then X squared. Plus X, or 1X that is, and then minus 56. So yeah, B is 1, and then C is negative 56. And again, if that seemed confusing, we're never going to do this again, because in the following video, we're going to teach factoring quadratics in a completely different way than the credit teaches it. So again, if you want to go through the credit the way it is, don't watch the videos for this credit. But if you want to learn what I think is a much more intuitive and just a way that makes much more sense, stick around, watch the videos, and let me help you how to understand what it means to, or how to factor a quadratic equation, and what the solutions mean in context to real life, context, and the graph.